Now I altered some wood. I changed up some wood sizes here, so it's still functional, I believe, but I think I'm going to save some weight without sacrificing the strength. So stick around to the end of the video, you'll see how I got to this point. So it's coming along good. I spent a lot of time on this they call it battery box, I guess, motor mount. So this replaces the crutch. So it's real critical you get this thing right. It's got to be square. If this isn't right, then it sets the stage for the rest of this fuse being off. So we spent a lot of time working on this battery box, motor mount. I might have to take a Dremel and enlarge some of these holes. I believe the battery goes in, you know, from the side, the way it looks, probably a hatch on the side. So yeah, well, looks good right now. So thanks for watching, thanks for coming by, and I hope you enjoy it. So I'm going to make the fuselage first here, cut these sides out. Let's go over the layout. So they've got two different versions here. They've got the IC version here, and then they got the electric version. And if you look, the plans are drawn with this former. These are all in line. This would be the F2G or F2E for electric. So the designation on these plans, F2G is the gas IC, we call it. But you come over here on these formers, you have some choices here. You have a former that's the F1G, but if you look over here, you have an F1E. So you're going to decide whether you want a gas or an IC, or versus the electric. So you're only going to have to cut out the electric version if you're doing the electric, obviously. So you come over here, this is all lined up, but then the plywood doublers and the fuselage is different from the IC or the electric version. The electric version looks like it extends out a little bit. If you look at the top view, the fuselage side ends here, which would be this dashed line. And then you follow that down on these plans. So we've got to take a measurement when we cut our fuselage sides from right here. Or if you want, you can just measure from this former back here and then add the length of the nose to it. Now what I've done here, since this is rounded and I want this measurement here, I want the full length. So I took this square and I lined it up with the fuselage top sheeting, and I just extended that line all the way down. So when I cut my fuselage sides, it's going to be squared off and back to start with. We'll put this radius in it later, but to start off with, this is the measurement it needs to be. So when I cut this side, it'll be square. So that gives me a reference point to measure off of right here. And always basically reference everything off of this on the fuselage. That's the continuous straight line on probably 99% of the designs. And then of course the bottom here, it usually angles up and then angles up from the gear back here to the tail. So I'm going to take a measurement here from this line all the way back to this line. And that's what I'm going to cut my wood at. So what I like to do when I pick out wood for an airplane, if it's opposing sides, top and bottom, left and right, I like to have the grain matching. So I picked out 2 sheets of wood with the same grain. And they call it book matching. So when they cut this sheet out of the log or the block, they just keep going down the log. And what you want to do, you want to find the right grain, which this is really straight and even, and you want the book match piece. So if you look at it, it's not a perfect match, but these 2 pieces of wood, you can tell were next to each other. And what that allows you to do is when you bend this wood to form the fuselage shape, it wants to bend evenly. Now you can force wood into a certain form and shape, obviously, when you mold and you wet it and you do all this. But I like to get really close to begin with. So it's important to me anyway. Now if you don't have any choice and you got to use what you got to use, you know, it's fine. But just be cognizant that, you know, when this thing starts to bend around the fuselage top view, you know, you got a better chance of it matching. So the first step, once you get your sheeting selected, is you got to get a true edge on the top. Let's see, it's 2 inches by 1 inch, and this is the same dimension. The 2 different dimensions on the wall thickness. This one's a little bit heavier wall thickness. This wall thickness is thinner. This looks more like a 16th. Now when you buy this scrap, these cutoffs, make sure they're straight. So what you do, you can bring a straight edge in there and check them all. But if you have 3 or 4 pieces sitting side by side, you can just start laying them together and seeing if you've got any disparity. So that's what I do. It doesn't really need to be trimmed. It just needs to be sanded. Here's the MDF top, and then I got 1/4 inch glass sitting on top of it. So what I like to do is take the sheet and I'll overhang it maybe a 16th of an inch right here, and then I'll weight it down so it doesn't move. And I've got other sanding bars here. Here's one that's 4 foot. Okay, so get another one. Here's a 3-footer. 3 foot covers the length of the balsa being sanded. Now if you don't have a choice, you got to use what you have, but ideally you want the sanding bar bigger than the piece you're sanding. You want the sandpaper to extend past the edge. And no sandpaper here or on top, so it allows me 2 different grits, top and bottom. And I just start out with the course, usually end at the course. So what I'm going to do is just set this down there. This will establish the 90-degree edge on this piece of wood. Sometimes when you cut with a razor blade, or almost all the time, what'll happen, even though you cut it with a straight edge, the blade will wander on the grain. And you'll still have to sand it, not so much for what I'm doing on a fuselage side, but if you're going to be doing wing sheeting, to get the edge to match up. This is all for reference. I wouldn't be messing with doing all this, but I'll throw it in here. So keep track of what edge you sanded here. So let's zero the scale out, or make sure it's still on 0. So you can see the come up to 0. Yeah, it's heavy wood, but heavy in density. I'm going to cut it up and make them into formers for the fuselage. Now on these formers, I want the grain running not vertical but horizontal in between the fuse sides. So by looking at it, I think I'm going to be able to utilize this wood. What I like to do, I like to run masking tape all the way over. As I push it down, I sort of pinch it together and make sure it's down pretty tight. Use blue tape, and then what I do is I bend it over the workbench like this, make a hinge out of it. Get some paper towel ready, need that, and get your glue set up to where you can just get a really nice bead. You just want to run a nice little stream right down the edge of the wood. Had some air bubbles in there, sort of wasn't perfect, but take the paper towel, double, triple it, and give it a good rub. And by rubbing it, it'll kick off, and then turn it over really quick. And make sure, you know, you're tight. Give that a rub. And that's all there is to it. This joint will be stronger than the wood. So these were pieces left over from the fuse cutout. I just glued them together. So these two pieces are going to actually be the battery box floor and the top. These two laminations I'm going to make are going to be the formers. Call it F1 and F2. They call it, yeah, F2E. And what it entails is taking these 3/32 balsa and making plywood out of it. So I've got all these little pieces pre-cut, and I'm going to laminate my balsa with opposing grain. Now, instead of using 1/64 ply, this is probably about 1/64, but what this is white oak veneer with a paperback face. It's basically one pump to one pump to get your ratio. So I've got all my grain set up here on these parts. Now these acid brushes that I bought are a different batch, different make, and I've been using different cups. And the problem I had making some landing gear was, for some reason, when I put the surface coat in, the actual surface coat, when I laid the gear up, it wasn't adhering to the surface coat. So I'm not sure where the problem arose. So it might be in the cup. They might have a release agent in the new cups, or the acid brush might have release agent in it. Now, you don't have to be too critical. All you're doing with this masking tape is just make sure the parts don't scoot around, slide, that you have bleeder and breathers. Since all we're doing is a little lamination here. So we'll put these in there. So instead of marking with a pen, I just make a tick mark with the X-Acto. So these will be the formers. Coming up a little short. Let's see if this trick works. And of course, if you get a leak, you just put some tacky tape on it. Okay, now let's back this out so we can get a little bit more. Looks like 19 inches of mercury. This was like I mentioned earlier, this is a bag that was meant to cook turkeys in. And the reason why I got this bag is to do high temp lamination. So if I wanted to actually put this in an oven I've got over there and do a high temp epoxy under some heat, this is the way to go with the high temp bag. And it's well, let's see how these turned out. This was sort of an experiment. So what I'm doing here, I'm cutting my former the same width as my battery box floor by lining it up with a aluminum tube here. I'm just using that as a guide because I know that's the width I need. And then there'll be a final sanding afterwards to get everything parallel. So now I've got 3 pieces the same width. The nice thing about tearing these plans up, I go down to a UPS store, 4 minutes down the road, another $8 I got a set. So since I'm not using all these notches here, I'm going to have to cut these things a little different. I got to have one a little longer to span the former there. Now one thing I'm going to do when I cut these formers for the height, I'm coming over here to the plan on the side view, I don't know, it just makes my life simpler though when everything fits. Now the beauty of this UHMW, one of the advantages I like about it, once you score it, and you can go back with a straight razor, get you one of these, it doesn't matter if it's sharp or scraper, you just go back here like this. And you either scrape the ridges off or you just flatten them down. I think I'm about there. I'm getting pretty close on all these. And then once I get to that stage, I just go around and check to see how square they are. Yep. So this will be my motor mount. This will be my former right behind my leading edge, or right in front of it, I should say. Now I can see right here it's a little high. Let's check it with this side. A little bit. So it's right here. So, yeah, I got to take a little bit off of right here. Yep. And once I get them all finalized here, I'll sand all these edges at once and make sure they're parallel. So this Alright, so got me some fresh sandpaper, good edge. I'm going to start sanding. So here's another one of these scrapyard finds. When I go into these metal places where the plastic warehouses, I always look in their scrap bin. And they had this big old block of UHMW. I thought, man, I could use that for something, I don't know what. It's been CNC cut with a CNC saw. And I just bought it not knowing if it was really square. And this thing is dead on. So, lucky me. So what I'm going to use this for is a fixture to actually hold this while I CA it. Now, obviously, you'd be better off if you used epoxy or whatever. But this will allow me to CA this box together. So I'll put a little medium CA down here. Now I'll go through the inside of this box later and probably put some fiberglass on it. You know. But so this will allow me to glue this box up and keep everything square. Now, the problem's going to be, obviously, when I get to the other side, but we'll deal with that problem when we get to it. So this is going to be the motor mount right here. And this will be the first former. But we get these two angles lining up, then the bottom will fall into place. That's my guess. Put that down there. Squeeze it against the block. Make sure everything's lined up. And then I like to move it around a little bit. Get it out of the puddle of CA you just made. And then give it a kick. So it just so happens this bar is 2 inches, and that's the width I need. So I just go around with this sanding bar and I just feel where I'm at. And make sure that I'm still staying parallel. Made a lot of motor crutches before. I've never made a battery box. The other thing you got to be careful of, you know, as hard as you try to make this square, if you line this side up with the top of the fuse, you got to make sure that the motor mount, the firewall, is 90 degrees. This is the really important. So it looks like now, I mean, I need to skew it a little bit this way because this isn't quite 90. It looks like it'd be up thrust. So I built in a little bit of tweak here. Let's see if I can get that out of there. I think what I'm going to do is just pick a hole that looks right. I'm not going to go with the drawing. Let's get a little weight out of it here. So with this Kutzall bit, this is a fine bit. Seems like it still works good, but it's getting a little clogged up. I'm going to put a little acetone on there. And what that does is it dissolves the CA. So I guess if you needed some out thrust, I'm going to have to put it in there behind the motor mount. I don't want to put this out thrust on the box. I want it to be built in behind the motor. That way I know this is zero. Zero up and down. Zero side to side. So then when I adjust the motor, I can tell exactly what I got. It looks like an 1 1/32 of an inch from the top. So let's come down 1 1/32. And all I'm doing with a 1/16 inch increment is splitting the difference. That's all I'm doing. Now to find the center of 2 inches, that's obviously 1. So I'll come over here and mark this center 1 inch. I'll put a vertical line. And I'll come over here and put the horizontal line. So that puts me in the center of that. And I think if I did the different KV, it wouldn't matter. This is all same series. These motors have all the same mounting bracket back here. So I'm just lining it up with the center right here. Put the crosshairs in the center. Looks like with these notches you get a little bit of wiggle in there. So we're going to drill these out for a 440. Put some blind nuts in there. So I guess if you needed some out thrust, I'm going to have to put it in there behind the motor mount. I don't want to put this out thrust on the box. I want it to be built in behind the motor. That way I know this is zero. Zero up and down. Zero side to side. So then when I adjust the motor I can tell exactly what I got. So I'm just going to go that route. So I think this box, for the most part, is almost ready to go into plane. Now, one of the things I need to do is drill the holes for the motor mount. And let's see what the plans are showing here. They're showing I'm coming down, it looks like an 1 1/32 of an inch from the top. So let's come down 1 1/32. And all I'm doing with a 1/16 inch increment is splitting the difference. That's all I'm doing. Now to find the center of 2 inches, that's obviously 1. So I'll come over here and mark this center 1 inch. I'll put a vertical line. And I'll come over here and put the horizontal line. So that puts me in the center of that. And I think if I did the different KV, it wouldn't matter. This all same series. These motors have all the same mounting bracket back here. So I'm just lining it up with the center right here. Put the crosshairs in the center. Looks like with these notches you get a little bit of wiggle in there. Doesn't have to be perfect maybe. And I believe if 440s ought to do it. It always worked on a 35 IC. So we're going to drill these out for a 440. Put some blind nuts in there. I'll go with 33. And once you get these blind nuts sucked in here pretty good, then I'll take some thin CA and take all this bolts out and see if I can get a little bit to wick around there without getting in the threads. If you ever get glue in your blind nuts or whatever, just go ahead and Get your tap out and run a tap down in there. Sometimes you gotta just sort of force it, I suppose. If I'd have known that ahead of time, I probably should have actually lowered this battery floor a little bit. I just went with the plans. It's alright, but I could have stood another 1/16 of an inch right there. The blind nuts hitting the floor. But at least it ain't going to come out. Put a little glue around that sucker. Now what are the chances of that happening? The blind nut went in the tube. That's crazy. So, we're going to put a big X right here. That's where the doublers go. So that way, we'll eliminate the risk of a catastrophic mistake here. So at this point, I keep looking at this thinking, okay, just how lucky can I get? How lucky can I get to place these doublers on this wood with CA? And that way you got time to position it, you can weight them down, and epoxy is the way to go. That being said, I'm going to CA them. Now you can already smell this CA starting to kick. You know, as soon as you put it on, you start to smell the heat. Well, I think we reached the point where we're going to get this fuse glued up. I got some lines. This is how far the fuse sticks out from firewall. And I did a mock-up. Anytime you do a glue up like this, get everything set up, get your clamps all ready, and that way you're ready to go. So this glue will allow me enough time to actually get this thing squared up. Now epoxy would have worked out fine, but this stuff's pretty good. Now if I was doing an IC engine, I'd have to go with the epoxy. I'm gonna make a mess here, but